Perfect. All right, so we're just going to start with a problem, and then I'll talk you through it, how to do it again. Okay, so factors, directions for everything. And this would be like one of the problems we did. So x squared minus 11x plus 24. I probably said this already, but factoring is the key skill for college, like the key skill for college. It really is. Until you finish math in college, you're not going to ever get rid of factoring. It's going to be here forever until you finish all your math you need in college. Okay, so what do? We try to find two numbers that multiply to be 24, but add to be negative 11. Add to be negative 11, multiply to be positive 24. And I gave you a chart last time, the plus, minus, minus, plus. So when you think of it this way too. I need a negative 11 in the middle by adding. I need a positive by multiplying. The only two things, only signs that will work would be negative and negative, because a negative plus a negative makes a negative, like a negative 11, and a negative times a negative is going to make a positive. So two numbers that add up to be a negative and a negative makes a negative, but multiply to be a positive has to be a negative. Okay, so then we start thinking about numbers that we can use for 64. So we have 6 times 4. I usually don't go to the 24 times 1 unless it's a big number. But then we also have 8 and 3 and 2 and 12. Now, which two of them multiply to be a positive 24? Now, knowing they're both a negative number, right? But will add up to be a negative 11. Well, it has to be, let's see, 6 plus 4 is 10. That's not work. 24 and 1 makes 25. That doesn't work. 8 plus 3 is 11. If I make a negative 8 and a negative 3, I will have negative 8 times negative 3 is positive 24, and negative 8 plus negative 3 is negative 11. So my factoring is x minus 8 and x minus 3. How can you check your work? Well, you can FOIL or double distribute. So if I just check my work real fast, I'll go x squared minus 3x minus 8x. Negative 8 times negative 3 is positive 24. And when I put the middle term together, I get negative 11x. And that's what I need. So you can always check your work on all of these if you're not sure. Factoring, you will not understand factoring until you really do it by yourself. That's when it starts clicking. You'll look at me and go, oh, that's easy. And then I give you a problem, you're going to go, I don't know what to do. That's normal. It's normal to struggle through factoring if you've never done it before, or if you haven't done it for a long time. Just know it takes practice. It takes practice. Just like anything else takes practice. Just like a sport takes practice. You get better with practice. Okay, so let's look at this one. X squared minus 2x minus 35. Okay, so going to factor. I'm going to put in what we worked on test day was also greatest common factor. I don't have any greatest common factors right now, but they're going to come back and we're going to put them back in a few minutes. All right, so I need two numbers. Let me divide this off. Two numbers that multiply to be negative 35, but add up to be negative 2. But what signs would they be? If I have a negative and a negative, so two numbers that multiply to be a negative, but also add up to be a negative, well, that means one of them has to be negative, one has to be positive, because a negative times a positive is a negative, and a negative plus a positive can be a negative if I do it right. All right, so let's look, 35. Well, 35, there's only really two things, 35 and 1 and 7 and 5 that I can think of. But if I make the 7 a negative and the 5 a positive, doesn't that make -2 if I add them? So -7 times 5 is -35, but -7 plus 5 is -2. And that's what I wanted. Two numbers that multiply to be -35, but will add up to be -2. The important thing is that that 7 has to be the negative. So I have to put the 7 and the minus together. And that means a positive goes to the 5. And if I check it by foiling or double distributing, I will see that I had the right answer. Okay, just what I said about greatest common factor. So that was just to warm us up, but look at this problem here. I think somebody's on. Just check your microphones. So whenever you factor, you always look for a greatest common factor. Can I factor anything out? Is there anything that I can factor out of this? Well, can I divide a number by everything? What's the biggest number I can divide everything by? 5, right? Now look at your variable. Do I have a variable that I can factor out? Is there an X in every single term? No, I don't have any X here with a 25. So I can factor out a 5. So first thing I have to do is factor out my 5. And then I have to figure out what's left. And then what's left is what I'm going to factor again. So if I think of it as dividing, which factoring is like dividing, you're multiplying and dividing it off, I get x squared plus 4x minus 5. So yes, we factored, but we did a greatest common factor. Now we have to see if we can factor this. Sometimes you can't, and sometimes you can, but you have to figure it out. So let's see, can I factor it? What happens to this 5? So this 5 just sort of hangs around. The issue is if you drop that 5, your answer is going to be wrong. But at the end, it has to multiply to be the beginning expression. So always make sure whatever you factor out, you bring down in the front and just let it sit in the front. Now we're going to concentrate on this. So I need two numbers that multiply to be -5, sorry, but will add up to be 4. So the only thing that multiplies to be 5 is 5 times 1. So one of them has to be negative and one has to be positive, but I want a positive 4. So I make 5 the positive and 1 the negative. Will it work? Hey, positive 5 times -1, that's -5. And positive 5 plus -1 is 4. And that's exactly what I wanted. Two numbers that multiply to be -5, but will add up to be 4. So I have an X, I have an X. I already know I want positive 5 and I want -1. And that's my whole answer with the 5 in the front. You can't drop that 5. I'm going to do one more, and I'm going to ask you if you guys have any questions. Factoring is difficult when you first start. It really is. And you have to sort of kind of know your multiples, your multiplying factors pretty well. If you know them pretty well, you can sort of see what eventually you're going to see what the numbers are going to be. It's hard to explain. Like you practice this, and all of a sudden, like the numbers just come to you. Oh, it's this and this. Oh, it's that and that. It just takes practice. Hey, first, can we factor out a greatest common factor? The answer is yes, because what number can I divide everything by? 2, but it starts with a negative. And what do we learn about when it starts with a negative? We have to factor that out too. Can I divide by X? Does everything have an X? No, my 20 does not have X. So my greatest common factor is going to be -2. We have to take the negative out, what's in the front. So I'm going to divide sorry. I'm going to divide everything by -2, -2, -2. And then we'll see what's left and we'll try to factor it. Okay, -2 divided by -2 is 1, so x squared. 12 divided by -2 is -6x. And -20 divided by -2 is +10. And if you want a quick check to see if you did it right, I'm going to write it down so you see it because I'm not in front of you in a board, but here in my mind, I'll go like this. It's -2x squared, -2x squared. That is -2 times -6, +12x. Got it, +12x. -2 times 10, -20, -20. Okay, so I know I factored that part right. I know this, they're equal to each other. So then we're gonna come down here and we're gonna go see if we can factor it. By the way, if you can't factor what's left behind, you're done. That's your answer. It'd just be -2 times that polynomial. But let's see if we can factor it. All right, so we need two numbers that multiply to be +10, but add up to be -6. The only way that happens, the only way is if they're both negative. A negative times a negative is a positive, and a negative plus a negative is a negative. It's the only way it works. So I know 10 can be 5 and 2, or it can be 10 and 1. All right, so if they're both negative, which they have to be, does any of them add up to be -6? Let's see. -5 plus -2, that's -7. -10 plus -1 is -11. There is nothing else that multiplies to be 10. So guess what? It wasn't factorable. And this is my answer.
I have a question.
Mm-hmm.
So
Go
on
for
our
it.
homework, there was a couple, well, actually most of the problems were just factoring, but there was an option for, is this like a prime factorial? So is that an example of a prime factorial where you can't factor it out?
Yes, that's a yes and no. So this is still a factor because we took a -2 out. But if I gave you just this to factor and said factor this, you would say, oh, it can't be done. That's prime. And that's what I was just going to talk about. If you can't factor it, they call it prime, which means there's nothing else I can do. I can't factor it, done. So this is still considered factored because I can factor a -2 out. This, I can't do anything, is called prime. So if you can't factor the whole thing, if you can't factor anything, let's put anything, it's called prime. That was a great segue. What I was going to talk about. It's beautiful. Yes, that's what prime means. You can't do anything.
Thank you.
You're welcome. Thank you for the questions. Beautiful. All right, so I told you I would stop here for questions. Any questions so far? Anything?
I have a question.
Sure.
So in this scenario, would you get the similar answer if you factor it out before you divide it by 2?
Divide by 2, if I factored it out to 4. The same problem, number 4? Oh, if I factor it out to 2 instead of -2?
Yes, ma'am.
Okay, so if you factor out to 2, that's a good question too. If I don't take the negative out, I'm going to be left with this: 2 times -x squared plus 6x minus 10, which is also not factorable, but will the online program let you put that answer in? I honestly don't know. But in math, we never leave a negative in the very front of a polynomial. So we're going to take, let's put it this way, we're going to take what we're learning now and we're going to do something else next time we meet, pretty close to next time we meet. And if it has a negative in front, whoops, we're in trouble. So a negative should always come out if it's in the first term, the very first term. So is it wrong? No. Is it completely factored? No. You might see something like this for your directions, factor completely. That means, is this completely factored? And the answer would be no, because that negative is still hanging out in the front. Did I answer that question?
Yes, ma'am.
Okay, perfect. It's a good question. Anything else? You guys all have
I
really
have
good questions. Go ahead, go for it.
I'm sorry. I just have a question. So if we don't put the -2 for question number 4, like let's say that's on a quiz or something, and if we get it wrong, but we only made that mistake, will we still get credit for it or no?
Yeah, that's why I
Like if we
checked all
show the
your,
work.
yeah, that's if you show your work, exactly. That's why I like you to show your work, because I go through and I give you partial credit back. You'd be surprised on the test you just took, how many of you got a good amount of points back because you showed your work and you might have had the negative answer and it was positive, or you forgot to simplify a fraction. And in the computer, they mark it all wrong. I gave you those points back. So yes, I would give you partial credit for that. Absolutely. Anything else? All right, I'm going to give you one to try, a small one. There's no greatest common factor. I just want you to try a small one. All right, so you're going to factor and make it number 5. I'm making it real fast. Hold on. Okay, you're going to factor x squared minus 4x minus 21. And just take a minute or two, think it through. I'll be quiet. All right, let's see how you did. How many of you feel pretty good about it? Good, yeah, I see it, good, good. If you don't, that's all right, we're still practicing. Okay, so the answer would have been x minus 7 and x plus 3. Did we get it? Hey, why is it 7 and 3? Because 21 can only be 21 times 1 or 7 times 3. But I need it to be multiply to be negative 21, but add up to be negative 4. So it has to multiply to be negative 21, but add up to be negative 4. So if I take 7 and 3, I know 7 minus 3 is 4. So it has to be 7 and 3. So 7 times 3 and 7 plus 3. So which one is negative? Which one's positive? Well, if I want negative 4, my negative 7 has to be negative. And I know negative 7 times 3 is negative 21. And then negative 7 plus 3 is negative 4. So my minus had to be with my 7 and my 3 had to be my plus. Hey, I'm going to add a page and we're going to do a few more problems before we add on to it. All right, we're gonna factor this. I'm gonna have you try this too. I see a very mixed class. Some of you I can tell have done this and are like fine. And some of you have not done this in a while or have never done it really well and are testing it out. It's good. All right, so our answer should be X plus 6 and X minus 3. Now, one thing I want to talk about too, it doesn't matter which order you put it in. It could be the opposite way. It doesn't matter. But what the negative has to be with a 3 and a positive has to be with a 6.
Okay, so that's what I was getting confused. I was like, I'm not sure if it matters which one I put it in. But
No,
mentally, I
no.
was like, okay.
Yeah, it's like multiplying like 5 times 3 is the same thing as saying 3 times 5. But I do want to make sure because sometimes students think, oh, it has to be the plus first. No, just that the 3 is negative and the 6 is positive, and you're good. Doesn't matter the order. That's for any of these. So if I write it in the opposite order you do, it's still the same answer. Okay, let's look at this one. All right, so number one, can I factor anything out first? Because the first thing I notice, I see even numbers. I see 2, 32, and 128. I know I can divide them all by 2. So, and if you're ahead of me, good for you. We can divide them all by 2, so we can take a 2 out. So whether you're doing it before me or after, what you get left behind is 2 parentheses, x squared minus 16x plus 64. If you are really good with your perfect squares, like 2 squared is 4, so 4 is a perfect square, 25 is a perfect square, 36 is a perfect square. It sort of helps you a little bit. See this 64? That's a perfect square. Isn't it 8 times 8? Right? And don't we need a negative 16? Isn't 8 plus 8 16? Right? So it's sort of kind of helping you a little bit when they're perfect squares. So we have 2. So we know 8 times 8 is 64. And then 8 plus 8 is equal to 16, but we need negative 16. So it has to be a negative and a negative and a negative times a negative. So they both have to be a negative. X minus 8, X minus 8. And negative 8 times negative 8 is positive 64. And negative 8 plus negative 8 is negative 16. Again, we could, I'll show you, we can FOIL or double distribute this to check my answer. should always check your answer when you first do these. So if I simplify this, I have x squared minus 16x plus 64. But do not forget that I have a 2 that I had to carry down. If I distribute, I get 2x squared minus 32x plus 128. Is that what we started with? Yep. So I know it's my answer. This way of writing the answer is perfect, but many times you're going to see it written a different way. You're going to see it written this way: 2x minus 8 squared. I do not care which way you write it, as long as you know they mean the same thing. All right, question on the last two. Eight, negative x squared minus, whoops, minus 3x plus 18. Now, this is considered factorable because we have a negative in the front. We got to take the negative out. So we can factor it. So we take a negative out. If I divide everything by -1, which is what I'm doing, I don't have anything else to divide it by. I have x squared plus 3x minus 18. So when I say factor a negative out, I'm really talking about factoring out -1, because negative is really just a -1. We just don't write the 1. That's really what you're factoring out is -1. And now we can try factoring this. We've seen something like this before. Oh yeah, a couple ago, I see it. Oh, it happens to be the same exact one, unfortunately. Okay, so two numbers that multiply to be 18, but add up to be 3. So 18 could be 18 and 1, 9 and 2, 6 and 3. Well, the two that will make a 3, when I add them together, would be a -6 and a +3. So -6 times 3 is -18, but -6 plus 3 is going to be, oh, I did it backwards. I take that back. +6, -3. That's why you check your answer. +6, -3. Okay. All right. 6 times -3 is still -18. And +6, that's supposed to be a negative, but you can't see it. Whoops. Let me write it better clearly here. Plus -3 is 3. So my x has to be, my 3 has to be the negative part, and my 6 has to be the positive part. Another way to tell, to help you, another little tip I can give you is that since 3 was positive, the bigger of the two numbers had to be the positive one. That's why 6 was positive and 3 was negative. So you look at the sign you want, the bigger number had to be that sign. I have one. I think I probably show you, I'll show you next one. Okay, 9. X squared minus x minus 72. You guys want to try it? Yeah, try it. Try it. Try it. I know 72 is a big number, but think of your times tables. It'll tell you what it is. I'm gonna write it down, but don't look unless you want. All right, if you think you're ready, look, see how you did. If you notice that we needed a -1, that's really what we have in the center, -1, and then the bigger number had to be the negative to make a -1. That's what I mean by you can check your signs that way. If you
Yeah,
need
I
a
think
negative,
it
the
helps.
bigger number has to be negative. Go ahead.
No, I feel like that one was actually easier than the other ones because like 9, 8, it's gonna leave you with 1, so one has to be a negative. But it
Yep.
was like the other ones
Yep.
were a lot harder.
It's because they had multiple things they could be. That's what I mean. 72 can be too. I say go with, if you're really good with your times tables, go with the first one that you have. Look, there's nothing wrong with trying it and being wrong and then try it again. Because at the beginning, that's what's going to happen. You're going to try something and you're going to check it and it's going to be right or wrong. And then you're going to try another combination. And then eventually, once you do that trial and error a few times, you won't have to do it anymore. You'll start seeing the answer. For instance, like 18, 6 and 3, 9 and 2, that's sort of kind of like 11, right? So if 11 was the middle, I would think 9 and 2, or 9 minus 2 is 7, but 6 and 3, that makes 18, but it also makes 3 if I subtract them. So you start seeing number combinations the more you try and the more you practice. Yeah, I think that one's too, because that first thing that comes to my mind is the times table. So don't, if the first thing, I say the first thing that comes to your mind, try that first. You'd be surprised how many times it's right. All right, we're gonna do one more like this, and then we're gonna add a little bit to it. So when you start seeing big numbers, like these are bigger numbers, you start to have to ask yourself, can I divide something by all of them? Is there? If there is, well, I know there is because they're all even numbers. I can definitely divide by 2, but could I divide by something more? Can I divide by 4? And the answer is yes. So 4 is going to be the number I factor out. That means we're going to divide everything by 4. So I'm left with x squared plus 28 divided by 4, 7x, negative 32 divided by 4, well, that's 8. And I'm going to show you what I see. See this 8? Isn't it 8 times 1, 8? But if I subtract 8 and 1, isn't that 7? Right? See how I sort of like see it? I don't think 4 and 2. I see 8. 8 is really close to 7. So if I make 8 positive and 1 negative, and don't be afraid to do it wrong. Let's say we'll guess. How if I go 8 x plus 8 x plus 1? Say I do it wrong. Then you're going to check. You're going to do your x squared, go through it, and you're going to see, oh, I have 9x in the middle after you check it. You're going to go, okay, I don't need 9x, I need 7x. But I also need a -8. I need to make one of them negative. But which one do I make negative? Well, I need a positive 7x. That means 8 had to be positive, and my 1 had to be negative. That's sort of kind of what you have to go through in your head to like understand these and be able to do these better. Is just sort of make mistakes. This is a perfect time to make mistakes. Make mistakes and work through how to fix it. Okay, questions before we add on a little bit. That was factoring what we call x squared plus bx plus c polynomials. Meaning that when we eventually factored, There is no number here, it's just 1. And now we're going to put a number in front of x squared. It makes it a little bit more complicated because we have different combinations of numbers we have to use. So that's what we just did. We worked on these. By the way, this is a standard, I don't even know if I even told you this. This is a standard form of a quadratic expression. So if you have a squared, that's the standard form for a quadratic expression, which you'll be learning soon. All right, so now we're going to be factoring this form of polynomials, ax squared plus bx plus c, which means we're going to have a number a in the front and a number c in the back and a number b in the middle. Okay, why don't you start with this one? 3x squared minus 11x minus 20. Now the question is, can we factor anything out? And 3, 11, 20, nope. X's, nope, 20 doesn't have an X, that's it, done. So we're in this form, ax squared plus bx plus c. So where a is 3, b is negative 11, and c is negative 20. That's what it means. I don't have to worry about that right now. That's what it means. So not only do we have to take into account 20, we have to take into account what things multiply to be 3. And then we got to find negative 11. So luckily 3 is only 1 and 3 or 3 and 1. That's all there is. 20 could be a few things. It could be 20 and 1, 2 and 10, 5 and 4. We have to find a combination of the front, which means we have to use this. It's the only one there is for 1 and 3, 1 times 3. So we got to use 1 and 3 in the front, and we got to find a combination of numbers to put in the back so we make negative 11. Gets much, much, much harder because we have to take both of them into account. And I'll tell you, for instance, what I'm talking about. Say, I just want to try one. So I'm going to do x plus and an x minus. By the way, if you have a negative, I think I did this once. If you have a negative sign for your second term, you're always going to have a plus and a minus as your signs. It's actually a really nice thing to memorize. Let me write it again. So if you have, this will help you, especially when we get to this part, signs. So if I have a polynomial that's a plus and a plus, when I factor, it's going to factor into a plus and a plus. If I have a polynomial that's a minus and a plus, when I factor it, it's going to be a minus and a minus. See how both of these are, the second one is plus? When the second one is plus, it's always 2 of the one before. So the second one is plus, is 2 of the one before. But if I have a plus and a minus, or a minus and a minus, see how this one's, they're both minus, the second one, I'm always going to have one positive and one negative when I factor. If you use this chart at the beginning, it's going to help you out, and then you won't need it for a little while. But that's how it factors. So if I have a minus as my second sign, I know it's one positive and one negative. All right, so like I said, I'm going to pick something. Say I pick 2 and 10. Okay, is that the right answer? I don't know. How are we going to know? We're going to check it. X times x is x squared. X times negative 10 is negative 10x. 2 times x is 2x. 2 times -10, -20. This is the key right here. Will I get -11? And unfortunately, I get -8. But that wasn't the right combination at all. And actually, I did it totally wrong, didn't I? Because I did, I forgot my 3. I forgot my 3. Take it back. Take it back. I forgot my 3 and 1. Okay, so I'll put the 3 here. Now let's do it again. Okay. X times -10 is -10. Boop, 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 boop. Messed myself up. Okay, 3x squared minus 10x plus 6x minus 20. So I have my 3x squared, I have my minus 20. What's that going to be? -4x. I need -11x. So that doesn't work. I could try changing these and going 10 and 2. And I could try it again. 3x squared minus 2x plus 30x minus 20. I got my 3x squared minus 20. I add it together. That is not 11x. So I can say this is out. Now, you can spend a lot of time doing this, right? A lot of time. This is what I want you to see. One and 3 and 5 and 4. 1 and 3 and 5 and 4. What combination, if any, will make -11? Well, 5 times 3 is 15. And 4 times 1 is 4. And if I subtract them, isn't 15 minus 4, 11? All right, we need -11. That means this had to be -15. So now, if I can get 3 and 5 together and the 4 and 1 together, I can make this work. So if I put the 3x here, the x has to go here because 3 times 1 is 3. That makes my 3x squared. The 3 and 5 have to go together, which means the 5 has to go here. So when I multiply them, it becomes 15x, which means the 4 has to go here because that's going to make my 4x. I need to make one of them positive. Which one's negative? Well, I need a -11. My -15, I have to have -15. So my negative has to go here and my positive has to go here. And that is my answer. So it's finding the combination of the right numbers to put together to make that -11 happen. And at the beginning, you might do a little trial and error to get it. Let me try another one.
I have a question.
Uh-huh.
Do any of like the rules that you put for like the signs, do any of those change? Like if there is a 1 involved?
A 1 involved with with
So like I had a problem on
no.
the homework where like the sign was like minus whatever X and then plus whatever.
Right.
But my answer, instead of being a minus and a minus, it was like plus, no, it was minus this number plus 1.
Got it. No, it doesn't change with 1. It's the same signs. This would be good for any factoring, the signs. It has to do with that middle number. That's the key, this middle number. Those 2 numbers you pick have to add or subtract to be that number. And well, I say add because they're going to be negative. They have to add up to be that middle number. That's where the signs come in. So when I first teach factoring, I have my students have this chart out in front of them. And every time we do one, we do the signs first. And then we start looking at the numbers. And I was going to show you another shortcut how to do these. By the way, there's tons of ways to do factoring. Every teacher teaches it a different way. This is a traditional way of factoring. And the idea is, and it does work very well, as long as you practice. If you're just gonna not practice, you're never gonna get this. I promise you, you will never get this. But if you practice, this gets very easy, very hard at beginning, very, very hard and frustrating. But traditional way is the fastest way to factor once you get it. And when you do algebra, you need to do as fast as you can. There's lots of different techniques you can find anywhere on how to factor, and they're cute little things like a box method and an X method, and you might even learn it that way. Does any of that sound familiar? A box method, an X method. You can use it. That's fine. But I want to show you the way that mathematicians want you to factor in college. That's how they want you to factor. But there are little cute little ways you can factor, which is a different way. I guess it's a way to organize your thinking versus seeing it and picking out the numbers you see. If that makes any sense. But if factoring is not your thing, after you practice and practice and practice and practice, and you cannot get factoring down, you need to email me and I will show you a cute little shortcut, not a shortcut, a cute little method, but it works. But I prefer you do it this way first. And then if you really, really, really can't get factoring, get up with me and we'll talk about a different way to factor. But I want to keep this way for now, because if you get it, you'll get it. It's the easiest way to learn factoring once you get it. Okay, let's try another one. I'm going to change it to a different variable because I just a whole bunch of X's, but it doesn't have to be X. Okay, instead of writing down things that multiply by 10, I don't think 10 and 1 is going to work. So I'm just going to write down 5 and 2. I may be totally wrong, but I see 5, 2, and 3, and I sort of kind of like it. Maybe I'm wrong. Okay, and then 4 could be 4 and 1 or 2 and 2. I'm not quite sure if that will work. But I forgot to mention, always ask yourself if you can factor anything out. Can I factor anything out? No, I have a 4, I have a -3, I have a 10. No T's all the way through. I can't factor any of that out. Okay, so we're going to go to factoring. So by my little chart, if I have a negative as my second one, I know that I have one positive and one negative. Sometimes I think doing the sign first helps. Now, I know this is a T. I know this is a T2. Whether it's 2 and 2 or 4 and 1, I'm not sure. But I'm going to stick with 5 and 2. I'm just going to put the 5 somewhere. I'm going to put the 2 somewhere just to start. I'm not going to think about anything. I'm just going to start. There's my 5. There's my 2. Okay, so now let's try 2 and 2. 2 and 2. I'm going to tell you right off the bat, it cannot be 100% 2 and 2. I'm not even going to multiply it. I know it's wrong. Hey, you want to know why? Because could we factor anything out from the beginning? Could we divide everything by 2? No. Look here. Doesn't it say that I can factor out 2? Doesn't it say they're both divisible by 2, right? If they're not divisible by 2 in the beginning, they can't be divisible by 2 here. Impossible. It cannot be 2 and 2 because no matter where I put 2, I'm going to have a 2 here. Whether I put 2 here and 2 here, or 2 here and 2 here, I have 2. It cannot happen. So if you can't factor at the very beginning, you cannot factor within here. For instance, if I put a 10 here, impossible, because I can divide both of them by 5. Impossible. I couldn't divide from the beginning. I can't divide when I factor. So I can rule out that 2 and 2 right off the bat. It cannot be 2 and 2. I cannot put a 2 here because that means I can divide by 2. And I could not divide by 2 from the beginning. I can't do it when I factor. So I'm going to 4 and 1. So how do I know we're right? I'm going to check. Now, if you are very careful with how you place your numbers, there's only 2 things you need to check. I want your eyes to go outside and inside. Look outside. 4t times 5t, negative 20t. inside, 2 times 1t, positive 2t. Does that equal negative 3t? No. What am I going to do? I'm going to switch my 4. I'll put the 4 here, and I'm going to put the 1 here. I'm going to try it again. Look outside, look inside, outside, inside, outside, negative 5t, inside, positive 8t. Does that make negative 3? Ooh, no, but we're close. It makes positive 3t. All right, when that happens, there's only one thing we need to do. Change our signs. If you get the right number, but the wrong sign, I just have to do this. I gotta make that a negative and make that a positive. Just change your signs. And now when I check it, I will get a positive 8t and a negative, sorry, negative positive 5t and a negative 8t, which will give me negative 3t. And that's my answer. T minus 2 times 4t plus 5. That's my factoring for that polynomial. Three. Let's do 16d squared minus 54d minus 7. Okay, we got a really big number in the middle, 54. We'll have to think about that. But 7 is awesome because all I have is 7 times 1. So right, oh, by the way, can I factor anything out? No. So I can put a 7 and 1 right in from the beginning. And I know my signs because the second is a minus. So I know 1 is going to be positive, 1 is going to be negative. So all I really have to figure out is what I'm using for 16. Am I using 16 and 1? Am I using 4 and 4? Am I using 8 or 2? So 16 and 1, 8 and 2, 4 and 4. 16 and 1 seems really big. I tend to not do them unless I have to, because it's the only one left. So I'm just going to take that out for now. So it's going to be 4 and 4 or 8 and 2. So let's try 4 and 4. All right, so once I place them, we're going to look outside and inside. We're going to multiply outside, multiply inside, and see if we have what we need. So that makes negative 4d. That makes 28d. And I put them together. I'm not even close to 54. That's not even close. It's 24. Not even close. So that tells me that I don't think it's 4 and 4. I think it now is 8 and 2. It needs to be bigger. So let's try 8 and 2. Let's try 8. Let's try 2. I think that will give me a bigger number. And actually, I'm going to erase that. I just saw something. I'll show you what I saw. If I put the 8 here, isn't 8 times 7, 56? Isn't that pretty close to 54? Right? Then if I put the 8 there, I'm going to put the 2 here. And then we're going to see if that works. But I like this combination of 54, 56. It's really close to 54. Well, let's see if it works. Okay, now we're going to check outside, inside. Outside, negative 2d. Inside, 56d. If I have 56 minus 2, that's 54d. That's what I wanted, but it's the wrong sign. I need negative, not positive. So I'm going to go back and I'm going to make this a positive, and I'm going to make this a negative. And I will have my answer because this is now negative 56 and positive 2, which makes negative 54. So your goal shouldn't be really where's the plus or minus go. Just know that one's a plus, one's a minus. And at the end, you can always flop them if it's the wrong sign. Your goal is to get that middle number. All right, let me do one more and I'll ask, see if you guys have any question. This is the hard part of factoring. I think this is the hardest part of factoring, actually. All right, let's do. I got a whole bunch of them in front of me. Let's do 12x squared plus 43x plus 35. Hey, now I have a plus as my second sign. If you look back at the sign chart, a plus means, if I have a plus and a plus, it means when I factor, I'm going to have a plus and a plus. So I'm not worried about any negatives at all. It's all going to be positives. Now 35, I'm pretty much going to think it's 7 and 5. I don't think it's 35 and 1. Again, I might be wrong, but I think 7 and 5 is going to work better than 35. So I'm going to go my gut and say 7 times 5. Again, I might be wrong. I'll go back, but I think it's 7 or 5. Now I got to figure out for 12. I don't think it's 12 and 1, only because 12 is pretty big. Again, I might be wrong, but let's do, we have 4 and 3 or 6 and 2. That's what I'm thinking. It's one of those combinations, but I need 43, right? So for instance, if I put, this is what I'm seeing in my head. I did some things in my head with numbers. If I put a 6 here, 7 times 6 is 42, right? But 5 is going to bring it over 43. If I go like this, it's going to be over 43. So that's not going to work. But can 6 go here? That would make 30. And this would be 2. That would be 14. And that makes 44. And that's too big. So I'm thinking, first I thought it was 6 and 2. I don't think it is. I think it's 4 and 3. So let's look. 4 and 3. This would be 20. This would be 21. That's 41. We're close. Still not, no cigar yet. So let's try it backwards. 4 and 3. I'll put the X's in a minute. This should be 15. This should be 28. And guess what I get? 43. That's my combination. So I have X and X. That's my answer. All right, I'll stop for questions. When you get really good at
So
this, you can
is
do this
that-
really fast. Mhm.
So is
ahead.
that like really your only way of doing this is basically just like plugging stuff in and trying it?
There's different ways to do it. There's different ways to organize. Like I said, there's something called like a box method and there's an X method and some people do factor by grouping with these and some people do this. There's tons of ways to factor. This is the way that I wish every student learned first and got it, because at the end, this makes you so much better in math if you can do it this way. I know it's hard and I know it's a pain, but I'm trying to model like how you would do it at the beginning. Because I can factor this right away. I know exactly what the answer is by looking at it because I've done it forever. But this is how you start. You start by trying it out and going through it. And like I said, if
Yeah,
you
this
try,
is like how my teacher taught me, and like
Mhm.
I don't have a problem like getting the answer. It just is like really time consuming problems for me, because that's basically like what I have to do though, is like what you just did, like plug
right,
something in, see if it works. If it
Yep.
doesn't, try this, you know. I was
Yep.
just wondering if like, I mean, that's cool. That's what we're supposed to do.
Yeah, that's what you're supposed to do. And what the thing is that the more you practice, pretty soon you can look at it and go, oh, I know it's this and this number. You sort of see it. I don't know how to explain it. If you practice enough, all of a sudden the numbers come up in your head and you know which ones go together. It really does happen. All my students, everyone I've ever said this to, eventually will go, oh my gosh, I know the answer by looking at it. It just takes a lot of practice and practicing by doing this. And it's seeing the combinations of numbers. When I saw like this, when I realized this is here and that's 56, that was my key. 56, 54, I bet you that's it. So it's putting the numbers together. 28 and 15 was 43. So putting those numbers together. It does take a while though, at the beginning. And then you get really good at it. I don't know if you've seen, I don't know how to do the box method. I know how to do the X method. I don't know if you've seen it before, where you put a number up top here and a number here, and you try to figure out how to factor it. I don't know if you've ever seen it, but the reason the X method doesn't work for most of it is you're going to multiply the first and last number, and that's a huge number. And then the X method gets complicated because you have this huge number you got to deal with, and you don't know what to do. So this really is, in my opinion, the best way to do factoring. Even if it takes forever at first, it won't the more you do it.
So obviously this is just the beginning of what I guess unit 3 will have, or is that I guess, is it going to be the same as the second test, that it's not as much problems because these are a little bit more time consuming?
Yeah. Well, see, this is a problem of our summer class, because we have factoring and then our next class, we're putting factoring into use. So it's like, it's not enough time to get it to be something unless you put a lot of time in right now till the next class. There's not enough time to really get real comfortable with this unless you really put the time in now, because there is no more time. Like in a regular session, we can spend like 4 classes on factoring. We can't. We're in a very short, tight schedule. So we have long classes. So that counts up to 4 classes because they're long. But it's all in one day, which this is hard to do all in one day. It really truly is. It's nice if you can do it in a little class and then come back and do a little more in another class and do a little more in another class, but summer schedules don't allow that, unfortunately. So you picked a very hard class to do in a summer schedule. It really is hard. It's a lot. But we could do it. Yay, we could do it. Yes, we can do it. We can definitely do it. We can do this. So if you're willing to put some time in this weekend and really practice these and practice, by the time we get back and do our next thing on Tuesday or Monday, you're going to be okay. But factoring is going to be here. I'm looking at all those things we're doing. Factoring is going to be here till the very, very end. I'm looking. Yep, going to be here. But we're good. Factoring is great once you get it. It's awful till you get it. It's great once you get it. All right, so let's look at another one. 6w squared plus 19w plus 8. You have to be willing, this is what I say, you have to be willing, you have to get comfortable at being uncomfortable. Doing this is going to make many of you uncomfortable and you're going to feel like you can't do it. You can 100% do it. You got to get comfortable at being that uncomfortable, because then you'll get past that uncomfortable and all of a sudden this is going to make sense. It's like, oh, this is not so bad. But you have to go through those motions, just like anything else. You learn to ride a bike. Are you going to be perfect? No, you're going to fall down. You're going to get scratches. You're going to get bruises. You're going to bleed, right? It's the same thing. You have to go through all that uncomfortable stuff of trying to figure this out and getting frustrated and want to throw your math book across the room. I've been there a million times, just like you guys. At one time in my life, I was just like you guys. But then you have to work through it and go with it. And I like to say, you have to get comfortable at being uncomfortable, because that's how you learn. When you get frustrated and you push through it, that's how you learn. Go ahead.
Have you ever heard of the method? I don't know what the heck it's called, but I learned it in one of my previous instructors, where you take the first, when there's no greatest common factor, so like the problem that you have currently, when there's a number in the front and in the back, where you take the integer in the front and then you times it by the back.
Yeah. That's what I was talking about. This one, we would have to multiply 35 times 12, and that number would be in the top, and that'd be a really hard number to deal with. That's why I don't like doing these special methods, these other little special methods, because they don't always work. 35 times
That's
12
true.
is huge. Like, I don't know if we could figure out 35 times 12 and how to break it down. 48 is not so bad, but when you get to bigger numbers, these special things that ways a factor don't work. This will always work if you learn how to do it and get more comfortable with it. That's why I stay with it. Yeah, someone said they use the box method, much quicker for me personally. That's fine. If you do the box method, I don't know how the box method works. It's sort of kind of like my X method, but you still have to multiply the first value by the last value, and you have to deal with that number. And that's a big number to deal with. And I don't know, if you're good at the big numbers, great. If not, you guys have, you guys can use your calculators that might help you, etc. All right. So this is really the way to do it. In my heart, this is the way to do it. But if you don't like this way and you're not going to get it, just do me a favor. Promise me you'll try and give it a really good go, and not like, oh my gosh, I'll never be able to do this, and you just don't do it. Give it a go. Give it a go. And if this really isn't for you and you just can't get it, I will show you another way personally, one-on-one. I'll show you a different way to do it, but it's not the way I really highly suggest to do it, because once you get the big numbers, it's very hard. Box method as well, but that's what you do. Go for it. Box method. The other methods take a lot of time, and where we're going, you might not have that much time to factor these in math. Where you're going in math, not where we're going, where you're going in math, you might not have that time to draw the box and figure out the things and multiply and put it all together. There's a lot of steps to that. Anyway, that's just my opinion. I thought very, very hard about how I want to teach this, and I kept coming back to this way. This is the best way to learn. It's the hardest way to learn, but at the end, it is the best way to factor. And once you learn it, you'll always know it. No matter what, you'll always know what to do. Okay, so now we have this polynomial. So I know 8 is 8 and 1 or 4 and 2. I know 6 is 6 and 1 or 3 and 2. I know the middle number is 19. I'm just going to go for it, and we're going to say 3 and 2 and 4 and 2. And I'm going to say that I'm wrong. You know why? Ready? Here's why. If I do 3 and 2 and I use 4 and 2, don't I have 2 2s that I can factor? Yes. Could I factor from the beginning? No, can't happen. Let's say I switch them and I do 2 and 4. Does this also tell me I can divide this by 2? Could I divide by 2 from the beginning? No, can't happen. It can't be 4 and 2. It can't, because it doesn't work. So I'm thinking 6 and 1. Or maybe I mean 6 and 1, 8 and 1. 8 and 1 is right. 6 and 1. Oh, 8 and 1. I did it totally wrong. I did it totally wrong again. I'm telling you, after COVID, my mind is like a big fuzzball. I'm trying to get my mind back. It's really bad. Okay, now 8 and 1. 8 and 1 goes in the back, not 3 and 2, or 6 and 1. 8 and 1 goes in the back. So 8 cannot go here because it divided by 2. 8's going to go here, and we're going to try 1 here. Okay, so will it work? I don't know. We're going to try. Okay. If not, I'm going to try 6 and 1. So I'm going to do my outside 3x. My inside is 16x, and that makes 19x. I just found it. It's all about eliminating. I couldn't use 8 here because 2 and 8, I divide by 2. I can't divide by 2. It can't happen. If you can't simplify or divide by the very first problem and divide by something, you can't divide a factor by it. Now, if this didn't work, I would switch to 6 and 1 and find a combination that worked. Let's try this one. 16p squared minus 34p minus 15. All right, so 4 and 4, 8 and 2, 16 and 1. I don't think it's 16 and 1. I don't also think it's 15 and 1 and 5 and 3. I might also be wrong. So number 1, I have a minus as my second. So I know it's plus or minus. I'm going to go with 5 and 3 without really thinking about where to put them. And then do I want to do 4 and 4 or 8 and 2? 4 and 4. 2, 8. Okay, so this is what I see. Ready? If I put 8 here, 8 times 3, negative 24. If I put the 8 there, the 2 has to go here. Five times 2 is 10, but it's positive 10. That only gives me negative 14, not negative 34. But let me try something. I like that combination. I like how it was close. It was really close, right? So let me try something. Let me try switching these. Let me see if this makes a difference. 5 and 3. Of course, P and P. Okay, so that's negative 40. This is 6P. What's negative 40P minus 6P? Negative 34P. So I found the right combination. And again, trial and error, but if that didn't work, I go to 4 and 4 and see if that would work. If I tried 4 and 4 first, it wouldn't work and I'd have to go to 8 and 2. All right, I'm going to a new page because now we have to add something to it. So now, what do you do when you have a greatest common factor? The same thing we just did. You know when you're going to get a greatest common factor? No. I'm telling you because I made a problem this way, but you always have to look for it. What can I divide? Is there a number I can divide everything by? I can divide everything by 3. Can I divide everything by W? No, because 9 doesn't have a W. So my greatest common factor is going to be 3. So I'm going to divide everything by 3. I'm left with 4W squared plus 8W plus 3. And just like before, I cannot forget my 3. I factored it out. So 3 has to come down, and I'm going to try to factor what's left. All right, so 3 is 3 and 1. There is nothing else it can be. I'm going to put 3 and 1. I look at my sign, I have a plus. So I have a plus in the front. I know it's a plus and a plus. I have a W. I have a W. Now I'm just going to figure out, do I want to use 4 and 1 or 2 and 2? So this can be either 4 and 1 or 2 and 2. So let's try 4 and 1. 4, I'll just put a 1 here to hold the spot so you can see a 1. So I look at my outsides. 4W times 1 is 4W. I look at my insides. 3 times 1W is 3W. Ooh, close. That's 7W. That's not 8W. It's really close, like really close. Okay, so since it's close, let me switch to 4 and 1 and see if I can get it. I tell you it's not going to work because 1 times W is 1W. And this would be 12W, and that's too much. That's 13. So now that I tried 1 and 4 in 2 different spots, I'm going to get rid of 1 and 4, and I'm going to try 2 and 2. 2 and 2. 2 times 1 is 2W. 3 times 2 is 6W. If I add them together, I get my 8W. So this is my answer. And like I said, this is a process. It's a process. It's a learning process. Eventually, you won't have to try anything. You're going to know it's 2 and 2. and 3 and 1 and put it in the right order like that. There's someone sent me the answer. All right. Just for you guys, I'll show you what I know is the X method, which I think is a box method, just a different way of saying it. I want to show you once, just so you can look at it. So forget everything I said. Let's go back to the beginning. I just want to show you what it means. You still have to factor out the greatest common factor. You still have to, no matter what you do. 3, that's 4w squared plus 8w plus 3. And I'm looking at this polynomial only. So I'm going to do it as an X. You can do it as a box. What do? You multiply your first and last numbers. Put it in the top. You take your middle number, put it on the bottom. You have to find on the sides. First, we'll look at the signs. The signs are going to be plus and plus. I like putting my signs in. So we have to find two numbers that will multiply to be 12, but will add up to be 8. Well, there has to be 6 and 2, right? 6 times 2 is 12 and 6 times 2 is 8. 6 and 2. Here's the key. You have to divide both of them by the first coefficient. I got to divide both of them by 4. And if you do not simplify, you'll have the wrong answer. It has to be simplified. So if I divide by 2, I get 3 over 2. If I divide by 2, I get 1 over 2. And then what you do, I mean, it's probably different what you guys do, but I have my students put the W in the denominator. And what you do is you go backwards. One of my factors is 2W plus 3. I'm going backwards. And my other factor is 2W plus 1. And then I take my 3, but I can't forget, and I put it in front. That's the X or box method. Yeah, it's nice. It's faster if you have smaller numbers. It gets really hard if you have bigger numbers, but this will be faster once you learn it and get better at it. You guys like that? Yeah. All right, let's do another one. I'll do it both ways. Let's see what I'm gonna do. Okay, minus 15 t squared plus 22t plus 8. I'll do it both ways. I'm gonna put it over here too. All right, number 1, I don't care which way I do it. I cannot have that negative in the front. Can I divide by anything else? No. So I have to factor out that negative first. So it means I'm dividing everything by -1. All right, so I get positive 15t squared minus 22t minus 8. And then I'm going to do this side first. I'll do the other side second. All right, the second sign is negative. That means one's positive, one's negative. I know I have a t and a t. I just got to figure out my combination of 8 and 15 to give me negative 22. So 8, of course, is 8 and 1 and 4 and 2. And then 15 and 1 and 5 and 3. And I'm going to bet it's 5 and 3. So I'm going to put 5. I'm going to put 3. I don't know. I'm thinking 2 and 4, maybe. Let's try 2 and 4. 2 and 4. All right, what we got? Let's check it. Outside, inside. 10t inside 12t. If I add it together, I get, Hold on a second. Negative, negative, negative. I need negative, I need an 8. Yeah. Negative out. Negative. Did I write something down wrong? Hold on. I wrote the problem down wrong. That's why it's not working. This should be a minus, which means this is a plus. Sorry. I knew that does not work at all. I knew something was wrong. That should be a plus. That means that these have to be, when it's a plus and that's a minus, they have to be both negative. Now it works. The way I had it would be a not factorable after the negative out. Hey, now that makes negative 22t and I'm good. So that's my answer. All right, let's do it the X way. But first, oh, wait, first, still have to factor it out, So negative 15t squared minus 22t whole, let's just put it minus, that makes plus 8. All right, I'm just doing what's in parentheses. So 15 times 8, 120. And I have negative 22. You take the signs with it. So you multiply the first and last, and you bring down the negative 22. So I need two things that multiply to be 120, but will add up to be negative 22, which means they have to be negative and negative, because a negative plus a negative is a negative 22, and a negative times a negative makes a positive 120. So 120 and what will make 22? 120 divided by 12 and 10. 12 and 10 makes negative 22. Now, I did that real fast. Doesn't mean you're gonna find it first time. You might try 6 and 20, 4 and 30, 30 and 40. You gotta find the right combination. I just did it real fast because I saw it. All right, now I have to divide by the first number, 15. And if you forget to simplify, it's not gonna be right. So you have to simplify. Negative. I can divide both of them by 3, which makes 4 thirds. And I divide this side, I can divide both of them by 5, which makes negative 2, whoops. Negative 2 thirds. And then I take my t and I put it on the bottom because we're going to read it backwards. So this becomes 3t minus 4. This becomes, trying to do my arrow. I don't have enough room over there. Okay, this becomes 3t minus 2. And I cannot forget my negative in the front. And I did something wrong. What I do? This would be 5.
Yeah.
Yeah. Sorry. I knew it doesn't look right. This would be 5. Divide by 3 makes 5, not 3. 5. There you go. And did I get the same answer? I don't have the same answer. 3t minus 4. 3, because I did it wrong. Yeah, hold on. Again, it's that COVID thing. It's driving me crazy. All right, so. All right, let's do it again. Divide by 3 is negative 4 over 5. That's good. Okay, divide by 5 is negative 2 over 3. Now let's do this again. Okay, so that's just a t and that's a t. Now we have 5t minus 4 and 3t minus 2, and we can't forget to bring the negative down. There you go. If I could divide right, it'd be great. I don't know. I guess you can pick which one you like. I think that's a lot of work too, especially when a number gets bigger. Okey-dokey. All right, I want to go back to something we learned already, but I just want to remind you, whoops. Sorry, I just want to remind you on how to do it, because you're going to see it again in this chapter and another section. Factor by grouping. If we have time left, I'm gonna come back and we're gonna factor some more of the ones we just did. So factor by grouping, you want to look for 4 terms. When you see 4 terms, you should think, I'm going to try factor by grouping. And again, we did this already, but I want to make sure we bring it back so you remember. I want you guys to get good at it. So x cubed plus 3x squared. This is like a factor by grouping problem. All right, so it's sort of backwards. You group and then you factor. So you group the first 2. Always a plus, and you group the second 2. All right, now, one thing I probably didn't mention because we just started learning it is that if this does not work and I try to factor, I can rearrange the order of my terms and try factoring a different way. This is going to work, but sometimes you might have to reorder them to get it to work. This will work fine. So factor out the greatest common factor of my first parentheses. I can factor out an x squared. And what do I have left? I have an x plus 3. And then I go to my second parentheses. What's my greatest common factor? I can factor out a 5. What am I left with? X plus 3. And then the answer is, what do they both have? X plus 3. What's left over? X squared plus 5. And that's done. So what do they have? They both have x plus 3. What's left over? X squared plus 5. Factor by grouping. And notice it's 4 terms. 2. We can also do it with different variables. This happens a lot with different variables, actually. Plus yx plus x. Okay, I'm going to group first. Always a plus in the middle. And then we're going to find the greatest common factor of each parentheses. So my first parentheses, they both share a y. I can divide both of them by y. What am I left with? I have 1 y left plus 1. Really important not to forget the 1. Remember, you're dividing by, dividing by y, which means y divided by y is 1. So that 1 has to stay, still there. And then plus, I can take out an x this time. And if I divide everything by x, I'm left with y plus 1, which is perfect because these 2 have to match. If they don't match, you either did it wrong or you have to rearrange them and try a different way. But they match, so we're perfect. Hey, what do they both share? Y plus 1. What is left behind? Y plus x. And when you multiply that through and double distribute or FOIL, you're going to find that you have exactly the right answer because this will pop right back out. And then one more I want to do just to sort of just remind you again, 20x to the third plus 30x squared minus 4xy minus 6y. After I do this one, we'll take like a 5-minute break, but I'm starting it right in 5 minutes, so we still have a good amount to do. What time is it? Okay. Okay, so group 20x to the third plus 30x squared, always a plus. That means that negative or minus goes with a 4. Look at your first parentheses. What's the greatest common factor? Well, I can divide both of the numbers by 10, right? And I could divide both of them by x squared. So 10x squared, 10x squared, 10x squared. Okay, what am I left with? 20 divided by 10 is 2, and x to the third divided by x squared is just x. 30 divided by 10 is 3, and my x squares will cancel. So it should be 2x plus 3. So now your goal is to get 2x plus 3 here. That means it worked. And if not, then we'll have to go back and look. But what can I factor out? Well, first, it starts with a negative. I gotta factor a negative out, and I can divide 4 and 6 by 2, and I can divide both of them by y. So I can factor out negative 2y. The question is, will I have 2x plus 3? So let's see. So I divide by negative 2y. So negative 4 divided by negative 2 is 2. X is going to stay. Y is gone. Negative 2y. Negative 6 divided by negative 2 is positive. 6 divided by 2 is 3. The y is gone. And yes, they match perfectly. Now, what do? What do they share? What's left behind? But is that completely factored? No. Look here. Can't divide this by 2. You know why? Because we could have divided by 2 from the beginning, but I didn't even see it. That's all right. We didn't divide by 2 first. We divide by 2 here. That means I can divide by 2. So that means 2 is going to go in the front of the whole thing. I'm going to divide both of these by 2. This parentheses is not going to change at all. We're just dividing that second parentheses by 2. So we have 5x squared minus y. And that is what we call completely factored. Because I can't factor anymore. So whenever you're done, ask yourself, is there anything else I can do? And that's what happened here. Yep, there was something else we could do. We could still divide by 2. All right, 5-minute break. I'm looking at it. 37. So we start at 42. Take a 5-minute break, stretch, go to the bathroom, get something to drink, grab something to eat, take a break.
You right? I sent a picture that they needed a bigger tent, and I got 3 replies.
What?
I sent a picture that they needed a bigger tent, and I got 3 replies, 1 from Drew and 2 from Kaylin.
Which says,
They love the comment, and they love us and miss us and hope to see us. And Drew said, yes, I already decided I need a bigger tent.
I actually love the dogs.
Oh.
That's so cool.
Oh, just playing in the woods and
Our dogs are like that. We should take them in the woods, let them go.
you okay? Yeah. Don't know.
Okay. All right, I'm starting. All right, sometimes, I'll say this rarely, it doesn't happen a lot, but sometimes we have to use substitution to help us factor. That would be when you have a really complicated polynomial. And then we're going to rewrite it so we can factor it. And that's where substitution comes in. We use substitution.
Is this 5-7?
It's still the same one, 5, 6, still 5, 6. The very, very end, 5, 6. Yeah, 5, 6 is a lot. Okay, so I'm going to show you what I mean, but as soon as you see this one, you'll see why it's called a complicated one. Okay, 4r plus 1 squared plus 8 times 4r plus 1 plus 16. And you're asked not to multiply it out, but you're asked to factor it. All right, so that's pretty ugly. I know, I think it's pretty ugly. Okay, so what we do is we use substitution. That's really complicated how to factor. I wouldn't factor it that way at all. All right, so we're gonna let x equal what we have in parentheses, 4r plus 1. So we're gonna substitute wherever 4r plus 1 is, we're gonna put x in. And you'll see it turns into something that we've done. So if I put x in place of 4r plus 1, I get x squared plus 8x plus 16. Now that is something that we can totally factor. All right, so we know we have x and x. We know it's plus and plus. What two numbers multiply to be 16 but add out to be 8? That would be 4 and 4. Now, just to make it a little simpler, we can put x plus 4 squared. We don't have to, but we can write x plus 4 squared. Now, that's not our answer because we made up x. X was 4r plus 1. So now that we factored it, we have to put x, the 4r plus 1 back in. So x comes out, wherever x is, we put 4r plus 1 in, and we still have our plus 4. And now we have to simplify the parentheses. So 4r plus 5 squared. That is way easier than trying to factor it the way it was. So whatever's in parentheses, you make x or y or p, whatever you want, substitute it into something that you can factor. You factor it. Once it's factored, you take the x back out and put in the original part and then simplify, and you have your factor. All right, so let's look at the second one. These do not come up that much. Honestly, they don't. But they do come up. That's why you have to know how to do them. But they don't come up a lot. All right, so I don't like the z plus 2. I don't want to factor z plus 2, so I'm going to make that my x. So x is equal to z plus 2. And that means wherever z plus 2 is, I'm going to replace it with x. So I have 3x squared minus 19x plus 6. And now this is definitely something that I can factor. Okay, it's parentheses, parentheses. 3 is 3 times 1, so I know it's going to be 3x and it's going to be x. I know that. All right, my second sign is positive and my first sign is negative, which means they're both going to be negative. Now, all I have to do is find the combination that gives me 19. But if you put 6 at the very end and you look at the outside, you get negative 18, which means I put here 1. That's negative 19, and I got what I want. I got negative 18 minus 1, negative 19. This is my factoring with x. Now we have to go back and put in our z plus 2. So wherever x is, we're going to put z plus 2 in and then simplify. So the first parentheses we have to distribute. So we have 3z plus 6 minus 1. Our second parentheses, we can just add 2 and -6, which is -4. And lastly, I can fix my first parentheses. 6 minus 1 is 5. And I have my factoring without having to factor that mess. All right, one more I want to show you with these. This one's more common than the other two. 14x to the 4th plus 23x squared plus 3. You can also use substituting for this. Why would you do that? Because we're used to x squared and x, not x to the 4th and x squared. So if I make, now this is x, right? So I'm gonna make, I'll make it y. Y is equal to x squared. If I do that, I'll get 14. Okay, so if y is x squared, then this is going to become y squared. Do you see why? X to the 4th is x squared squared. And if x squared is y, that makes y squared. Plus 23y plus 3. And now it's something that I can factor because I have a square and I have a y and I don't have a 4th power and a 2nd power. All right, so now we're going to try to factor this. I know 3 and 1 is going to be our last. 14, I'm thinking 7 and 2. Let's see. Or not. 7y and 2y. I don't think that's going to work. Let's go back. Let's look. Okay. 7 times 3 is 21y. 1 times 2 is 2y. Oh. I just get it. $23y. All right, now I have to go back and we have to substitute back our x squared. So it would be 7x squared plus 1, 2x squared plus 3. Again, that happens rarely, but it does happen. So there's something that you're not used to factoring, you can use substitution to make it something that you factor. That's the whole premise. Okay, all of that was 5, 6. All right, let's look at 5, 7. 5, 7 is actually on the other side, very small. It's still factoring, but has to do with special factoring. So it's factoring, factoring special products. One, two, I think there's 3 we're going to do. Okay, the first one, perfect square trinomials. So 3 terms that use special perfect squares, like 4, 16, 9, 25, 49. perfect squares. So if you can recognize your perfect squares, it's probably like 90% of the time a special product. This would be a perfect square trinomial. We actually did one or two already without even talking about it. So why is it called a perfect square trinomial? Because 36 is a perfect square. 36 is 6 times 6. But look at this 12. 6 plus 6 is 12. So 6 times 6 is 36 and 6 plus 6 is 12. So it winds up being 8 plus x plus 6 times x plus 6. It's a perfect square, which we can write as x plus 6 squared. And that's why it's called a special trinomial, because it deals with perfect squares that factor into a perfect square. This is a perfect square because it's x plus 6 twice. Now, this is also a perfect square trinomial, harder to see. How do we know it's a perfect square trinomial? Because 16 is a perfect square. Because it's 4 times 4. X squared is a perfect square. Because it's x times x. And y squared is a perfect square. Because it's y times y. They're all perfect squares. The only thing not perfect square is the middle, and that's the way it usually is. So if I were to factor this, I'm going to think of these numbers right here. What number multiplies by itself to be 16? 4. What number multiplied by itself, or its variable multiplied by itself, is an x squared, x. Y times y is y squared, y. I know I have a minus and a plus, which means it's going to be minus and minus, and the two are identical. They're perfect squares, which I can then write as 4x minus y, the whole thing squared. So just by deciphering the perfect square part, you know how to factor it. I knew it had to be a 4x and a y. And does that make, we never checked, but does it make negative xy? Yeah, because when I do my outsides, I get negative 4xy. And when I do my insides, I get negative 4xy, which is your negative 8xy. It comes out perfectly like that because they're perfect square trinomials. Three, 25x squared minus 50x plus 9. So I'm just going to go right to my parentheses, and I'm going to use my perfect squares. 5 times 5 is 25, 5 and 5. X times x is x squared, x and x. I look at my signs, I have a plus and a minus, which is minus minus. And then I look at my 9, 3 times 3 is 9. And I think I actually wrote it down wrong. Hold on a second. Ooh, I really wrote it down wrong. That should be a 30. Sorry. With that 50 at 30, I wrote it down wrong. And then that would be 5x minus 3 squared. And if you want to check, that's negative 15x. And that's negative 15x. Whoops. Which gives me my negative 30x. Perfect square trinomial. You can leave your answer this way without doing a square or with a square. Unless your math lab says they want to enter it as a perfect square trinomial. This is your perfect square answer. If it doesn't say, I'll take either way, I'm sure. Four. 16x squared minus 8xy plus y squared. Okay, 16, 4 and 4, perfect square. X squared, x and x, perfect square. Y squared, y and y, perfect squared. I have a negative, I have a positive. That's a negative and a negative. If I check it, that's 4xy or negative 4xy. This is negative 4xy, and I get my negative 8xy. They sort of kind of fall right in place. But I can write it that way, or I can do 4x minus y squared. Hey, sometimes they'll give you something that looks like it's a perfect square trinomial. It is, but there's something you can do first. Okay, so what's the hint that something has to be done first? Number one, this x at the end is not squared. It's just an x. It has to be squared. Plus, then I look and go, okay, wait. They all have an x and they all have a number I can divide by. They don't all have y, so I'm going to have to do my greatest common factor first. So what number can I divide them all by? 4. And I look at my x's. I have an x to the third, an x squared, and an x. And I take out my lowest exponent, which is x. My smallest x, which is x. Now, I'm going to divide everything by 4x. Okay, 64 divided by 4 is 20. Wow, I can't even divide in my head. Ooh, 27 x cubed. Is that right? No, x squared. That's not right.